All right, guys, I am going to give you 15 minutes of a video answer key, and that is it because we went over so much in class, and I have already emailed out a printable one. So I'm going to be starting with learning objective 1. I'm going to go through the problem with the roots, even though we did cover these in class. I still think there are going to be questions on this, and not all classes went through this. So on these problems for the roots, my goal is to take out as much as possible that's perfect. So on the first one, square root of x squared is x. Same on the other one. And then in the denominator, when I take out exponents, remember you do this through division. So the square root of x to the 16th is not x to the 4th. I'm dividing the 2 into the 16th, so it's actually x to the 8th. So working on my answer for a numerator, I have 6x squared, and on a denominator, I have 81x to the 8th. If you leave it like that, that's pretty good, but hopefully you can see that with your numbers, you can take a um, 3 out, and when you take a 3 out, you're left with 2 over 27, and then my x squared, x to the 8th, I can subtract, and I get x to the negative 6, which starts out in the top, but then the negative is going to move it to the bottom. So there's my final answer for number 1. On 2, with exponents, according to the flow chart, I should deal with any parentheses, which means I distribute the 1/2 to each thing. 25 to the 1/2 is like the square root of 25, so I get 5. A to the 10th becomes a to the 5th, and b to the 16th becomes b to the 8th. And there's your final answer. On number 3, again, I'm dealing with parentheses, so I'm going to distribute to each thing. I'm going to start with the numerator. So 3 squared, x to the 1/4 is going to become x to the 2/4, or 1/2. Y to the 2/3 is going to become y to the 4/3. I'm multiplying 2 with 2/3, and z will just become z squared. As far as my denominator, the 2 goes to everything there as well. So I'll have 2 squared. X will just become squared as well, and 1/2 times 2 is just 1. And so cleaning this up, 3 squared over 2 squared is 9 over 4, and I cannot simplify that as a fraction. For my x's, I'm going to subtract the exponents. So I'll be taking 1/2 minus 2, which is negative 3/2. The negative starts out on the top, but then it's going to end up in the bottom because of the negative exponent. I'll be taking for the y's, 4/3 minus 1, which is the same as 4/3 minus 3/3. And there I get 1/3. That's on the top because it's positive. And, whoops, the z has nothing to combine with, so it just stays where it is. There's that one. All right, moving right along. I'm skipping ahead to number 16. If you just flip over, when it says rewrite it as a log, remember we are just looping. Loop around the equal sign. So go 6 to the x power equals 216. That is all you are to do. Just loop it. Okay, now I'm jumping over to the objective 2 I can solve, and I'm looking at 23. This has the correction on it, just so you notice, in case you didn't get it. Inside the square root is 5x plus negative 14. So to get the x by itself, what I'm going to have to do first is square both sides. Oops, hold on. So I'm going to square the left side, and I'm going to square the right side. Squaring the left side just gets rid of the square root. And then when I square the other side, x minus 4 squared really means x minus 4 times x minus 4. So you really have to FOIL. You just can't make it x squared minus 4 squared. So foiling x minus 4 times x minus 4, I get x squared minus 8x plus 16. Because I have 2 types of x's, I'm going to bring everything over to one side. So when I do that, I get x squared minus 13x plus 30. And my factors of 30 that get me to negative 13 are going to be negative 10 and negative 3. So I have x minus 10, x minus 3, and when I set those two equal to 0, my final answers are 10 and 3. Let's jump over to the log problems, and I know I'm going fast, but I'm giving you 15 minutes. Remember, constants you loop, without a constant you don't loop. So there will be no looping on problem 27, 30. Again, this is no looping. 33, and 34. So let's start with the exponent ones. With the exponent ones, you need to use your cheat sheet and find the row that has both 3 and 9 in it. So I jumped to the cheat sheet real fast. 3 and 9 are both in the row with a base of 3, so that's where I'm going to start. So the left side is good to go because it already is a base of 3. And the right side, to make it into a base of 3, it's 3 squared. That's the same as 9. So I still have 9 to the x plus 1 power. Now that the bases are the same, I'm going to ignore the 3's and focus on the exponents. I'm going to go ahead and distribute the 2 in, and now I just have to get x by itself. So bring this x to join the 2x, that's x. Bring this 2 over here to join the 2 by subtracting. When I'm done, my answer is 0. Now, for instance, on 33 with a fraction, again, just looking at the cheat sheet, the fraction comes from being a negative exponent. So I'm looking on my cheat sheet for 6 and 2/16 to be in the same row. And when you do that, you'll find that right here in your base of 6. So I'm going to rewrite this with a base of 6. So 1/6 is the same as 6 to the negative 1, and now I have it to the 3x plus 2 power. And 6 cubed is 216 to the 4x power. Now that my bases are the same, I'm just going to ignore them, distribute my negative 1 in, multiply the 3 and the 4x. I'm going to add the 3x to the right side, and now to get x by itself, I'm going to divide by 15. So my answer is negative 2 over 15. All right, just as far as the other ones go, remember, if there's a constant, you'll loop. 26 is going to loop into an exponent. 3 to the 4th power equals x. And as it turns out, 3 to the 4th power is just 81. There's your answer. 29 will loop into a log. This is the way I loop. So the base 3 becomes the base of my log, so 310 equals x. I need to use the change of base formula, so log 10 divided by log 3. I know I'm going fast, but again, you get 15 minutes. When I type that into my calculator, I get 2.1, and that is my answer for x. Let's see, let's go over to 31. Again, there's a constant, so I'm going to loop, but I can't loop until it's just 4 to the x, so I'm going to add 3 to the other side and get 14. Now I'm ready to loop. It's an exponent, it loops into a log, so there's the loop. So the base of 4 becomes the base in the log. 14 equals x. Again, I would have to use the change of base formula on my calculator. And when I type that into my calculator, I get 1.9. And that's my answer. That's x. I think I'm going to call it good on the solving for logs. Let's jump over to the graphing. I'm going to take a little closer look at the graphing with the logs. So I think I covered number 7 in almost all the classes, so I'm just going to start with 6. A is 1, and B is 3. And since B is bigger than 1, I have growth, which means I have a backwards L. My y-intercept and A are the same. My left-right number is negative 2. I do not have an up-down number, and that makes my wall 0 because those are the same. And when I make my t-chart, because it's growth, I want to use 0, which I already have for my y-intercept of 1, and I want to use 1 and 2. For my t-chart, I leave out h and k. I will only use 3 to the x power. So 3 to the first power is 3, and 3 squared is 9. I'm going to put my points on there. And now I'm going to shift all my points to the left 2, and then I can draw my growth shape. All right, let's take a look at number 8. Because of the E, it might throw some of you off. When there's E, there's an R. So right now A is 1, B is E. I'm going to write 2.7. R is the negative 1. That negative 1 makes your 2.7 move into a denominator, and that makes B technically less than 1, so I will have a decay shape. My y-intercept, I know, 1, so I can fill that in. My left-right number, there is not 1. My up-down number is 1, which is my wall. And now that I know it's decay, I'm going to use negative 1 and negative 2. So going to my t-chart, I leave out h and k. I will use e to the negative x for my t-chart. So if x is 1, that means it's going to be e to the negative of negative 1, which is just e to the first. So I get 2.7. And when I put negative 2 in for x, that becomes e to the negative of negative 2. That becomes e squared, and e squared, I believe, is, hold on, let me find this page, 7.3. And now I'm going to estimate these points, more like at about 3, 7.5 maybe. So here's 0, 1. It'll be shifting, it won't stay there. Here's negative 1, about 3. And negative 2, I'm going to put it about 7.5. But now everything's going to shift up 1. And now I can graph my decay shape. Okay? Let's take a look at number 9. On number 9, I give you a clue. Since I give you a clue that the x-intercept is 1, you do need to write in the parentheses that would have gotten you there, x minus 1. So I'm going to use that shortcut or the trick, and I'm going to put in the numbers that belong to my x's up here. I have all my x's, so 1, 1, negative 11, negative 9, 18, and I'm going to go through my synthetic division. I bring the first number down, and now I'm going to multiply and add. So 1 times 1 is 1, add them up, I get 2. 2 times 1 is 2, add them up, I get negative 9. Multiply for negative 9, and when I'm done, there's 0. So the 0 is my remainder. This is my constant, x squared, x cubed. And now that I have 4 terms, I can group them, and everything should be factorable once you get done with synthetic division. So in the first set of parentheses, I want to take out as much as I can, which is going to be an x squared. And since I'm left with x plus 2, the other ones need to be x plus 2, and I'm going to take a negative 9 out of there to do that. The outside stuff becomes one set of parentheses, the inside stuff, or the matching set, becomes the other. So I'm going to add those two to my final parentheses list. Now when I set these equal to 0, x squared minus 9 is 3 and negative 3, x plus 2 is negative 2, and going to the original problem, my constant is my y-intercept. So I'm going to put those points on my graph. Here's 1, here's 3, here's negative 2, here's negative 3. And because of the fourth power, I'm going to have a bumpy u. None of the x-intercept points repeat, so it's going through. It's a positive slope since it's 1, so it's going up on the right, up on the left, sorry, to switch those around. But it's just going to go through the points. As I move left, right, go through the points. Okay, and there you go. That is number 9. All right, folks, I think I will take a look. Sorry, I accidentally switched slides. I think we can take a look at one of the cubed roots, square roots. Again, I'm looking at my cheat sheet. For this, for my cheat sheet, I focus on this column. And so using my cheat sheet, if x is 0, y is 0, if x is 1, y is 3, if x is 4, y is 6, and if x is 9, y is 9. My left-right number, remember that's contained inside the square root. I do the opposite, k as is, so adding negative 2. So now all my points go left 3 and down 2. Whoops, left 3. And now it's going to start and go this way. Remember, you guys, whenever we did our graphing, we never used H and K in any of our t-charts. We always wait till after we plot our original points, and then we shift with our H and K. All right, anything else we want to take a look at? I think that's it, you guys. We went over a lot in class. I've sent out a printable one. I guess I'll see you on Monday for the probability part review. Have a good weekend.